Hello and welcome back. We will continue looking at graphing inequalities, and essentially in this next example we're going to be looking at two inequalities at the same time. And when we are looking at two inequalities at the same time, we need that both are satisfied, so we just have to check two different inequalities, and there's nothing really more to it than that. Also, before I start this example, this is about medical things. I'm not a doctor. Don't trust any of this. This is just coming from the book. So let's dive in. If x represents height in inches and y represents weight in pounds, some guidelines from the book suggest that your height and weight should satisfy these two inequalities. 4.9 times x minus y should be greater than or equal to 165. And 3.7 times x minus y should be less than 125. The weights and heights that satisfy both of those inequalities are considered healthy. So the question is 130 pounds and 66 inches considered healthy? Does it satisfy both of these equations? Well, we just plug them in and check. X is the height. So let's check the first one. So we'll do 49 times x, which is going to be 66, minus y, which is 130. So the question is this greater than or equal to 165? Well, if we simplify this left-hand side, just plug this into a calculator. Really, 4.9 times 66 minus 130. If we plug this into a calculator, we get 193.4. And yes, that is greater than 165. So the first inequality is satisfied when y is 130 pounds and x is 66 inches. Let's test the next one. So we've got 3.7 times the height minus the weight, and this should be less than 125. And again, 3.7 times 66 minus 130, this is something you plug into a calculator, and this is 114.2. So the question is that true? Well, 114.2 is certainly less than 125, so yes, that's satisfied. So the answer to this question is yes. 130 pounds and 66 inches considered healthy, because when we plug both those values in for x and y, we get true statements. So the moral here is you just have to check more than one inequality, and that's all there really is to it. So let's graph the solutions to this system of equations. So we have, the system of inequalities. So now we have two inequalities here, and we can graph both of them. And essentially what the solutions are going to be is solutions to both of them at the same time, where they overlap. So let's get started. Let's focus on the first equation. So let's just graph where this first equation is true. We have x minus 3y is less than 6. Well, the first thing that we do is we replace that with an equal sign, and we'll graph this line here. So let's solve for y. I'll move x to the other side, minus x plus 6, and I'll divide everything by -3. So when I divide the left-hand side by -3, you just get y. Divide the right-hand side by -3, the negative signs cancel out, and I'll get 1/3 x. Dividing 6 by -3 will give me -2. So this is one equation. So let's graph that down here. I'll do this on this side. So we'll have 1/3 x minus 2. So minus 2 is going to be the intercept. And with a slope of 1/3, every time we go up 1, we go over 3. This was a strict inequality, so I'll use a dashed line. Cool. And what we'll need to do is make sure that we graph the correct side of this. Do I want to go above that line or below it? So for x minus 3y is less than 6, let's choose a point on one side or the other. A nice point I like is right here, so that's 0, 0. and that is clearly on the upper half, not on the lower half. So let's plug that in and see if this works. 0 minus 3 times 0 is less than 6, maybe. 0 minus 0, well, that's just 0, and 0 is certainly less than 6. So we are going to graph the top half. Cool. So, but we've only graphed one line here, and we have 2 inequalities. So let's do this other inequality. We've got 2x plus 3y is greater than or equal to negative 6. So solving this for y, I can move the 2x to the other side. So this is minus 2x minus 6. I have to subtract 2x from both sides. And now I can divide both sides by 3 to get that y is greater than or equal to negative 2 over 3x minus 2. Okay, so here's, and I've done a little bit of a mistake there. I want to do everything with an equal sign. So we'll have to just go back and pretend like I didn't make that mistake. So now let's graph our equation here. Y is equal to negative 2/3 x minus 2. So let's put this over here. So the y-intercept is negative 2 again. And now the slope is negative 2/3. So it means that we'll go down 2 and over 3. So if I go down 2 and then over 3, here's that. And this is coming from a greater than or equal to. So since it's greater than or equal to, we'll do this with a solid line. Again, we need to see, are we above the line or below the line? So let's plug in a point. One nice point I like to use is the origin, which is clearly on the upper half. So let's test to see if this works. So let's plug 0, 0 into here. 2 times 0 plus 3 times 0 is greater than or equal to negative 6. Well, 2 times 0 is 0, 3 times 0 is 0, and 0 is in fact greater than negative 6. So we are going to shade up here. So the question is, how do I graph where both of these are true at the same time? Well, it's just going to be where they overlap. So let's graph this down here. We have both of our lines. We have our original dotted line from there to there, so dotted line. And we have this solid line that's passing through here. And we want the area that's above both of these. So that's going to be, I'll try to do this in a different way, all of the area above both of them. So notice that there are a couple more areas over here. So the area in here is above the dotted line, but not above the solid line. So we don't include that. The area over here is above the solid line, but not above the dotted line. So we don't include that. The areas that we want, the areas that will overlap, are above both of them. So we want the area that's above the dotted line and above the solid line, and where they overlap is right here. So we're just looking to see where these guys overlap. Let's do another example. I think this one will help quite a bit. So we're going to graph the solution set to these two equations. So let's graph these two inequalities first, and then we'll see where they overlap. So the first one, again, we'll replace this with an equal sign. Y is equal to x squared minus 4. And already, right away, we know what this looks like. Y is equal to x squared is a parabola, and it looks something like this. But we're subtracting 4 from it, so we're shifting it down. So this should go roughly like this, and roughly like this. So we have our parabola here. Now, for a parabola, there are still two sides to the parabola. We might be shading what's around the parabola on the outside, or we could be shading the inside of the parabola. So we just have to decide, are we shading outside or inside of the parabola? So we choose a test point. Again, I like 0, 0, just because it's easy to plug zeros in for numbers. So let's plug zeros and zeros into here. So if I take, let me just wall this off. If I take 0, is that greater than or equal to 0 squared minus 4? Well, 0 squared minus 4, that's negative 4. And 0 is in fact bigger than every negative number. So we are going to shade where our test point is because we succeeded, and it's going to be all the way in here. Perfect. So we have graphed our y is greater than or equal to x squared minus 4. So now let's do x plus y is less than or equal to 2. Well, the first order of business is to replace this with an equal sign, and I have to solve for y so that we can graph this. So if I move this over, this is x plus 2. Nice. So when I'm graphing this, let's graph this right here. Again, we have it in slope-intercept form. Our slope is going to be -1, and our intercept is 2. So here's our intercept, and our slope of -1 means we go down 1 over 1, down 1 over 1. So our line is going like this. And notice that these are both solid lines because these are both greater than or equal to or less than or equal to. And then finally, we just have to decide which side of the line are we gonna shade on. And again, I think I'll choose my favorite point, the origin. So we're just going to plug in 0, 0, and we'll see if this will make the equation true. Sorry, the inequality true. So we'll plug this in. 0 plus 0 is less than or equal to 2. Well, 0 plus 0 is 0, and 0 is indeed less than 2. So everything seems to be working out. This side of the equation is where we will graph. So now we just have to put everything together. We have, let's use my noisy furnace. We have our original parabola, which crossed down here. And we have this line, which went right here, went down, and then up. So now we have to look at to see where these are going to overlap. This line, we want everything below this line. Oops. So that would be everything down here. But we don't want it all because we only want stuff that's above our parabola. So this region is above the parabola, and below this line is going to be the stuff that's trapped in between here. So again, all we're doing is we're looking at our two inequalities, which we can solve. We're looking for y is greater than or equal to x squared minus 4, which is everything up here. We're looking for everything that's x plus y is less than or equal to 2. And where they overlap, whereas solutions to both inequalities is right here in the middle. So I'll do one more video where I'll look at more than two inequalities.